Hello everyone, welcome to this video on hypothesis testing. Today we are exploring testing the difference between two means of independent samples using t-test. First, we are going to look at what we need to know before we use this test. The first thing that we must know is the two samples are random samples. So the process of selecting the samples for this hypothesis test should be random samples. Second, the sample data are independent of one another. We have two samples and those two samples should be independent of each other. Meaning of that is there should not be any kind of relationship between the two samples. Third, when the sample size is less than 30, or if the sample size is less than 30, in that case, your populations, both populations must be normally or approximately normally distributed. That's the third condition. Next, population standard deviations are not known, or the sigmas will not be given to you. Instead, the sample standard deviations for the two samples, you can say S sub 1 and S sub 2 will be given to you. Once you know that, in order to perform the hypothesis test, we know that we are going to calculate the test statistic. And here the test statistic is the t-value, which is calculated using the formula here, which is t equal to x bar sub 1 minus x bar sub 2, meaning the average of first sample minus the average of second sample minus the difference in the population means mu sub 1 minus mu sub 2, all divided by the square root of s sub 1 is squared over n1 plus s sub 2 squared n2. That's your t-value or the test statistic. Since we are using the t-test, we need to know the degrees of freedom. If we have only one sample, the degree of freedom will be sample size minus 1. But here, what we do is we find the sample size minus 1 for both samples, sample 1 and sample 2, and we look at these two values. The smaller of these two values, or the smaller of n sub 1 minus 1 and n sub 2 minus 1, the smaller of these two is considered as the degree of freedom. Okay, so that is the basic thing that we must know in order to perform the hypothesis test for difference between two means of independent samples using the t-test. Now we are going to use this and solve an example. Okay, here is the example. A random sample of teachers from two different schools are collected to study their average salary. The table below summarizes their statistic. So for school A, sample size is 15, average salary is 35,270, standard deviation for sample A is 3,256. For school B, sample size is 30, average teacher salary is 29,512 with a standard deviation of 1,432. Is there a significant difference in teacher salary between two schools at 5% significance label? Okay, that's our question. Here we have 5% significance label. Meaning of that is your alpha value is 0.05. First, we are going to write the hypothesis. So here, you can say that your null hypothesis is there is no difference in the teacher's salary between those two schools. So mu sub 1 is equal to mu sub 2. But we want to test, is there a significant difference in teacher salary? So your alternative hypothesis will be mu sub 1 is not equal to mu sub 2. We are testing this, so this is our claim. Okay, this is our claim. So we have the null and the alternate hypothesis. Now we need to calculate the test statistic using the given information. So for that, since the sample standard deviations are given, we use the t-test. And to calculate that t, it is the mean of first sample minus the mean of second sample minus the population mean of first population minus the population mean for the second population divided by the square root of S1 squared over N1 plus S2 squared over N2. Let me calculate that here. So T is equal to, okay, the average for the first sample is 35,270 minus X sub 2 bar is this one, which is 29,512 minus mu sub 1 minus mu sub 2, the difference in the mean, since these two are equal, that must be 0, divided by the square root of, okay, the standard deviation for the first, 3256 squared divided by N1 is 15 plus S sub 2 squared, which is this one squared, 1432 squared divided by N2 is 30. Okay, if we type all these in our calculator, our result will be 6.5401. Okay, 6.5401. That is your test statistic. Because we are using the t-test, we want to find the degrees of freedom. That is something you need to know. So degrees of freedom is the smaller of n1 minus 1, n sub 1 minus 1, and n sub 2 minus 2. So this one, the degree of freedom for this one is 14. Degree of freedom for this one is 29. So the smaller of those two will be 14. So degrees of freedom for our case is 14. Also, in the alternative hypothesis, there is not equal to sign. Meaning of that is this is a two-tail test. So the rejection reason is on the two tail, the left tail and the right tail. That is where we have the rejection reason. This is the rejection reason. And the p-value is the sum of the areas on the two tail. Okay, so this is t distribution with 14 degree of freedom. Okay, once we know this, now you know this value, which is calculated up here, 6.5401. By symmetry, the value on the left is negative 6.5401. Now let's find this area. The area on both sides will be equal. So that area will be, let's find it out using the t distribution. So we do second, then vars, and then t CDF, which is number 6. Lower limit negative infinity, upper is negative 6.5401. Degrees of freedom is 14. So if we paste this to the main screen and hit enter, we get this value. Because we have a negative 6 there, meaning of that is 0 followed by 5 zeros, and then this number here, 6. But when you round it, that is 7. So 0 followed by 5 zeros, and then 7. Okay, 0.000040 zeros, and then 7. And you have the equal area on the right. So your p-value, so the p-value is equal to 0.000007 times 2, which is equal to 0.000014. And you can clearly see this implies your p-value is less than alpha, because alpha is 0.05, 5% significance level. So p is less than alpha. Meaning of that is we reject null hypothesis. So we reject null hypothesis. Null hypothesis. Okay, if we reject the null hypothesis, we are rejecting this, so we are not rejecting this. Meaning of that is there is enough evidence to support the claim at 5% significance label. So yes, there is enough evidence to support the claim that there is difference in teacher salary. So that is the end of this short video where we tested the difference of two means of independent samples using t-test. Thank you for watching.